Hi, I'm Jason Brand. I'm 12 years old and I'm the creator, designer and pilot of Project ThunderStruck.
And I'm Robert Brand, and I'm not telling you my age. I'm his father, and I'm also the cameraman, as you might have noticed. So, Project ThunderStruck, a great idea I had. No, this is his idea.
Yeah.
I work in the space sector, and I was talking to him about building a winged re-entry vehicle and how we'd have to test it and so on. And there was the transonic phase we'd have to test. Transonic is what?
Supersonic, basically.
Breaking the sound barrier.
Yeah.
It's that area in there that has to go from subsonic to supersonic or vice versa. So he wanted to build an aircraft that would go supersonic, and he knew this because we've been launching high altitude balloons and we've been dropping payloads, and our last payload got to 33 1/3 kilometres, 1/3 of the way to space. We dropped it and it got a top speed of
400 kilometers an hour.
That's right, 250 miles an hour, and that's a long way towards breaking the sound barrier. It's a very low altitude to start from, but it did have a parachute deployed when it reached 400 kilometres an hour. So we are very confident that getting up to 40 kilometres plus is going to do the trick, and we know that Felix Baumgartner, who jumped from a balloon recently, a couple of years ago, managed to break the sound barrier just with his body from a lower altitude than we're going to drop our aircraft from. And it is an aircraft because it has active control surfaces, and they will be used to stop the aircraft from spinning and to make sure it stays in a vertical dive. Then we're going to pull it out of the dive once we slow down and go subsonic. So who's the pilot?
I am.
Yeah, where are you going to be located?
On the ground.
On the ground, because it's going to be a radio controlled flight.
Yeah.
We're not going to stick him up there in thin atmosphere and everything. So he's not jumping, he's not doing anything fancy that way. Very safe. But the radio control side of things, he's going to have to fly it once we release it. We're going to use a zero pressure balloon, and that's a big balloon that isn't tied up at the bottom, because our weather balloons only get to about a third of the way to space.
Yeah.
And so now we're going to go higher. We need to have a very specialised balloon, and that balloon alone is going to cost somewhere around $50,000. $15,000, sorry. Well, you can donate more, that's fine. Anyway, $15,000. And then once we release it and it goes through the sound barrier, it'll come back and slow down and go back through the sound barrier, and we're going to then have to fly it. I say the royal we, but who's going to be flying it?
Yeah, me.
You. Fly it all the way to the ground. So it is an aircraft. It has to be an aircraft at all times, and we're going to make sure we reach round about Mach
1.5.
1.5.
1,800 kilometers an hour.
Ooh. And that's about 1,200 odd miles an hour. So that's pretty fast, and faster than your jet airliner. And we're going to do some pretty amazing things, lots of things to break. He's only 12, that's going to be a new record. It's radio controlled, so it'll be in the radio controlled records as well. We're going to certainly convince you now that he's got the ability to do it, because he's planning on making it out of Kevlar and
Carbon
fibre. Why the Kevlar?
To let radio signals in and out.
So we need something super strong, but we'll still let radio signals in and out. We haven't checked Kevlar. Does it do that?
Yeah, it does.
It does that, okay. He knows this because he also has a license of some sort, which is a
amateur radio license.
Amateur radio license. He's had it since 9. He's been doing software programming on his computer. We have Arduino systems here. We've been doing a lot of work with radio networks. He's been designing a cut-down system with a 10-channel radio network, so we can control things as well as cut down the balloon and everything. So hopefully we'll be doing flying of payloads back to a certain area using steerable parachutes and so on. And we have to use cameras, or else we don't know where it's pointing. So while the rest of us are struggling with screens, the pilot will have what? on his head?
A pair of video goggles.
Video goggles. He'll be seeing the instrumentation using something called OSD.
Yeah, an on-screen display, so that shows me my speed, artificial horizon, altitude, and also my heading.
He knows the words. So basically, it's got to have a video transmitter in the aircraft that'll work over 100 kilometres, and we can make that. I think the weight's about 1.5 kilograms, well within the limits. Our aircraft will be 2 metres long. That's how much in feet?
6.
8 feet. We work in metric in this part of the world. Well, come to think of it, every part of the world except 3 countries. 2 are very tiny. One is called the USA. You know.
Sorry.
Anyway, yeah, some other small country we don't know the name of. Anyway, bottom line is we have the ability. He flies remote control models all the time. We've launched high altitude balloons, so many of them. How many?
19.
19 so far, another one this weekend. And we've recovered how many payloads?
19.
I love that number. 100% recovery rate, so we're very good at what we do. I drive, he sits in the passenger seat with the radios, the iPad, tablets, internet, radio systems, navigation systems, tracking systems. He does it all, I drive. He tells me where to go. Hang on, that's not right. But he does that, yeah. So bottom line is we've got the ability, we've got the experience, we've got the knowledge, and it's a very low risk operation. Now the budget, like I said, there's $20,000 for just the radio systems for the GPS. We need 2 of them and they're ITAR rated. We've got to have, because they're basically missile tracking systems because we're going faster than the speed of sound. And we also have to have radar transponders so other aircraft can see us. We need to have a backup one. We need the same with cameras. We've got to have cameras on the balloon, cameras on the aircraft, and cameras filming us for the. Because this is newsworthy. This is going to be in every news story around the world that day. This is a phenomenal thing for STEM education. That's science, technology, engineering, and mathematics. And with STEM and with having no limitations on what you believe you can do this sort of stuff. And this is really just an amazing opportunity to demonstrate how STEM actually creates massively important steps forward. Anyway, we've got the budget, we've got the timeline, we've got sponsors coming on board, and we need about $100,000. We assume we're getting about 60 from sponsorship. There's some crowdfunding, there's some other money going in, but we need $20,000 from you guys. That's you in there. And we need $20,000 minimum. If we get 60, we'll be able to do this really fast. We're planning on doing it in 6 months' time. If we get $60,000 from the KickStarter project, and we'll do this next
year, so April 2015.
That's right. That's the school holidays over here in Australia, so it gives us 2 weeks to get over there, and just transporting all this stuff to a remote area where the Civil Aviation Authority will let us do this, because we have to launch where there's no trunk routes for aviation and there's no population underneath. And Australia has the 2nd busiest trunk route in the world for aviation, Melbourne, Sydney, so there's no chance of launching very close to Sydney, and the population is certainly too dense. Hang on, I live in Sydney, I'm not dense, am I? Okay, so we've got to launch in a really low population area with nothing around, so we're going to have to transport a lot of people and a lot of stuff there. So we'll need as much money as we can get, and we'll make this happen for you, and we'll let you follow along live, and we're going to tell you the whole story, and we so look forward to making sure that KickStarter is a big part of that project.